Hi students, today I am going to continue carbon and its compounds lesson for class 10th. In the last video, I explained about alkanes and its structures, right? So we discussed about the general formula of alkanes, CnH2n plus 2, and also how to write its structures also. So now we will write alkenes. So these are unsaturated carbon compounds and these have double bonds. So and its general formula is CnH2n. So let's start with so first one carbon will not be there because with one carbon we cannot form a double bond, right? So we start with two carbon atoms. It's nothing but ethene. So ethene. So C2H2 into 2, that is equal to C2H4. Let's write its structure. C double bond C and H4. So for writing this, if we don't know the structure, we know only this one, then start writing a carbon-carbon bond and satisfy the 4 hydrogen atoms afterwards and just see its valency is satisfied or not. Carbon should have 4 bonds. So 1, 2, 3. Only 3 are there. Here also 1, 2, 3. So satisfy the 4 bonds. Double bond is necessary. So like this we can tell. And next with 3 carbon atoms, propene. So with 2 carbon atoms, with 3 carbon atoms, we will write C3H2 into 3. That is equal to C3H6. Let's write the propene structure 1, 2, 3. So 3 and so 1, 2, 3, 4, 5, 6. It's no 1, 2, 3, 4, 5, 6 is balanced. Then so 1, 2, let me complete it with hydrogen. So 1, 2, 3, 4, 5, 6 is balanced. Here we can see 4 bonds are satisfied. Here also 4 bonds are satisfied. But here it is having double, so it is having only 1, 2, so 3. So like this we can keep. So 1, 2, 3. 3 are satisfied. And here we can remove 1 because if we keep double bond here, what happens? It will become 1, 2, 3, 4, 5. So don't want 5. So we remove hydrogen here and we keep here. So the correct structure of propene 1, 2, 3, and so if we are keeping here, then only 1 hydrogen will be here and 2 hydrogens will be here. So 1, 2, 3, 4 satisfied, 1, 2, 3, 4 satisfied, and here normally 3. So like this we can write propene, and this double bond, it may change its position. Here I wrote, here also we can write. Let's do that also. Propene with the double bond in the first carbon atom. Then we can tell, so 1, 2 are there. So 1 more 2. So to satisfy 4. And this carbon, if you see 1, 2, 3 are there. So 1 more hydrogen to satisfy that. Here is 1, only 1 is there. So again 3 will come. So like this we can change the double bonds. So double bonds, and according to that hydrogen structures, hydrogens will be changed. Like this we can write propene. Next butene, 4 carbon atoms, 1, 2, 3, 4. Here also we can change the double bond. I am writing the double bond in the last carbon atom. So here 1 is satisfied. So remaining 3. Here 1, 2 is satisfied. So 2. Here 1, 2, 3. 3 is satisfied. 1. Here 2 is satisfied. 2. So total should be 4 now for every carbon. So like that we are writing butene, and we can change the double bond to here or here for the second carbon atom, or between first and second carbon atom, or between second and third, or third or fourth, so that hydrogens will change according to that. So this is about alkenes. Then I am going to write about alkynes. Alkynes are also unsaturated carbon atoms which contain triple bond. So general formula of this is CnH2n minus 2. So triple bond will be there. Let's start with the 2 carbon atoms, ethyne. So 2, 3 carbon atoms. Here only all the 3 bonds are there. One more bond is with hydrogen. So ethyne like this. Next write propyne. So 3 carbon atoms. I wrote in the first only. So 1, 2, 3 is balanced. So 4. Here 1, 2, 3, 4. All are balanced. No hydrogens. Here 1 is there. So 3. So 1, 2, 3, 4, 5. Let's check this. Propyne is C. Here CnH2n minus 2. So C3H2 into 3 minus 2. So C3 6. 2, 3 6 minus 2. C3H4. So I think it is satisfied. 1, 2, 3, 4. 4 carbon atoms. Here also C2H2. Because C2H2 into 2, 4. 4 minus 2, 2. So C2H2. Next, butane. Let's take. So 1, 2, 3, 4. Let me take here triple bond. So here it is 3 carbon atoms satisfied. Here 4 are satisfied. Here also 4 are satisfied. But here 3. So we can write like this. So and let's check the general formula also. So C4H2 into 4 8 minus 2. So C4H6. So 1, 2, 3, 4, 5, 6. Correct, no? So like this we can write alkanes, alkenes and alkynes. Let's see next the structure of all these. And benzene, we know benzene is C6H6 and it is a alkene structure. Yes, no? So C6H6, it is called cyclohexene. It is also called cyclohexene. So because it is hexene, 6 carbon atoms we can draw like this, and the double bonds are present. So like this, here 1 single bond, 1 double bond. So alternate double bonds will be present in the benzene structure, and so hydrogens will also be there for all the carbon atoms. So to satisfy, and this double bond will be rotating inside. It will not stay one side. So like this I can say the benzene structure. In the later classes, in the higher studies, we will get about the benzene. Next we will see, will you be my friend? So carbon seems to be very friendly element. So we have been looking at compounds like carbon, hydrogen only, but others also will form bonds with elements such as halogens, oxygens, nitrogen, sulfur. So in a hydrocarbon chain, 1 or more hydrogens can be replaced by these elements. For example, chlorine or bromine, it may be replaced by 1 hydrogen. So in such compounds, the element replacing hydrogen is referred to as heteroatom. So whatever is the element which is replacing that hydrogen atom, it is called heteroatoms. They are present in same groups. So these heteroatoms and the groups containing the confer specific properties. So because of these groups, it contain a specific properties regardless of the length and nature of the carbon chain. That's why they are called functional groups, because the properties of a compound will depend on the groups which they are attached. So the functional group is attached to carbon chain through their valency by replacing 1 or more hydrogen atoms. So if we see, if halogens are attached like chlorine or bromine to alkenes substituted for hydrogen atoms, they are called haloalkanes. Let's see this one structure of alkanes. So let's write first haloalkanes, how it is formed. Take one alkane as an example. Alkanes, let's take C3H2n plus 2. So 2, 3 6 plus 2, C3H8. So let's write the structure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So this is propane. This is propane, and one of the hydrogen is replaced with the halogen like chlorine or bromine. Let's take chlorine here. So we can write like this: propane with 1 chlorine, so attached in the place of hydrogen. So we can give the name as it is a chloropropane, or it is attached to the first carbon atom. So 1 chloropropane we can give. So if it is attached to the second carbon atom, then we can say 2 chloropropane, or both the hydrogens are replaced, then 1 to 2 chloropropane. So let's write that also. So when 2 chlorines are attached, this is like that only, and one more carbon also is attached with a chlorine, then we can say it is for first carbon, second carbon, chlorine is attached. So 1 2 chloropropane, like this we can tell. So like this the haloalkanes are explained. When oxygen is there, like alcohols, OH group, aldehydes like CHO group, ketones like C double bond O, and carboxylic acids like COOH. So depending upon these compounds, their nomenclature will be depending and their properties will be dependent. So they are called functional groups. And so we can see a homologous series also in alkanes. In alkanes, you have seen the carbon atoms can be linked together to form chains of varying lengths. Yes, no? So these chains can be branched also. In addition, hydrogen atoms or other atoms on this carbon can be replaced by some functional group also, as we saw. So if alcohol decides the properties of a carbon compound, regardless the length of the carbon chain, the chemical properties of methyl alcohol, ethyl alcohol, yes, no, propyl alcohol, butyl alcohol are similar. So for example, if we take first one methyl alcohol CH3OH, or ethyl alcohol, ethyl means 2 carbon atoms, ethyl alcohol, OH, if OH comes alcohol, then propyl alcohol C3H8OH, like this if you are taking, or butyl alcohol. So like this if we continue, these are all having same properties and they are called homologous series. Homologous series. So let us look at some example. CH4 and C2H6, they differ only by CH2 unit. C2H6 and C3H8. What is CH4, C2H6? Methane and ethane, they differ by CH2, and methane and propane, next element, by CH2. So next pair, propane and butane, again CH2. So they all differ in their CH2 unit, and between these pairs atomic mass of carbon is 12 and atomic mass of hydrogen is 1. So these are called homologous series. Like same in alkenes also, like this only, it will be differed by CH group, and alkanes also. So from this I already told the general structure of alkenes, alkynes and alkynes. What is the general formula of alkenes? CnH2n, and alkynes CnH2n minus 2, and alkanes CnH2n plus 2. So the chemical properties are solely depending on these functional groups on the homologous series. Then how do we name these carbon compounds? I already told. So there will be two parts, prefix part and suffix part, indicating the functional groups. For example, if we take methanol, this is called prefix, this is called suffix. Prefix, carbon structures are prefix and functional group structure is suffix. So if one carbon is there, one carbon atom is there, then we can say meth, and because alcohol is there, methanol. Or if two carbon atoms are there, then eth, and alcohol is there, ethanol. If 3 carbon atoms, prop, and alcohol is there, propanol. Like this we can give names of this. From this just I am explaining this. Haloalkanes I already explained this. This is called chlorine is there instead of hydrogen, so chloro, because 3 carbon atoms are there, chloropropane. Bromine is there, so bromopropane, and alcohol group is there, so propanol, or aldehyde is there, propanol, Al. So like this we can give the names. Still are there ketones, C double bond O is there, so propanone. If carboxylic acid is there, then we will get oic acid, Alkenes, if they are, then suffix will become "-ine." And if they are alkanes, then "-ine." Alkanes, "-ane." Like this, the suffix will be there, so that we can put the names, nomenclature, we can identify like this the elements. Then here something is given. See, how would you name the following compound? So what is this? How many carbon atoms are there? 2. So ethyl bromine. Then here, what is this? Tell me. So just comment the answers of this. If you have doubt, I will clear in the next video. Thank you.